In 1941, Henry Ford made a promise that stunned the world. One B-24 bomber every 63 minutes, rolling off the largest factory ever built, 80 acres under a single roof. 1 year and $200 million later, that factory had produced exactly 0 combat-ready planes. Ford believed a bomber was just a complicated car. He was wrong, and the reason why nearly killed the entire program. Henry Ford stood before the press in 1941, certain that the same moving assembly line that built the Model T could be stretched to build bombers. He promised a B-24 Liberator every 63 minutes under a single 80-acre roof, an industrial space so vast it could swallow a city block. The world listened, and Washington handed over $200 million, convinced that scale and speed alone would win the air war. Inside the new plant, Ford's team installed the largest presses and conveyor lines ever seen. But the logic was fatally simple: treat an airplane like a complicated car. In Detroit, stamping out fenders to a tolerance of 1/16 of an inch was good enough. On the B-24, the Davis wing demanded precision down to 1/1000th of an inch. The difference is the gap between a door that rattles and a wing that snaps at 30,000 feet. The Davis wing, with its slender, high-lift profile, was an engineering marvel on paper, light, efficient, and able to carry heavy bomb loads. But it was also a nightmare for mass production. Ford's automotive presses warped the thin aluminum spars. Holes drilled for rivets wandered out of alignment. Generic jigs and static fixtures, perfect for car bodies, left the long, narrow wing boxes twisted and out of spec. Each new design revision from Consolidated Aircraft made the tooling obsolete before it could be dialed in. Quality control fell back on visual checks, just as on the old car lines. There were no statistical process charts, no micrometers tracing the edge of a critical spar. Parts that should have been interchangeable had to be hand-fitted one by one. Rework piled up. Assemblies stalled. The plant's own logs recorded man-hours per plane in the hundreds of thousands, with no finished aircraft to show for it. By the end of that first year, the scoreboard was brutal: 0 combat-ready bombers delivered. The largest factory in the world, built on the promise of industrial genius, had produced nothing but scrap and excuses. The myth of the bomber an hour was already turning into a national embarrassment, and the question echoing through the halls of Congress and the War Production Board was blunt: would Willow Run ever run at all? Winter at Willow Run brought more than cold. 42,000 workers crowded into a sea of wooden trailers, each row lined with coal stoves and communal latrines. The camp's single well barely kept up with demand. Frozen pipes and overflowing toilets turned daily life into a test of endurance. Absentee logs from December 1941 tell the story: a 7% no-show rate, with over 150 cases of respiratory illness reported in a single month. Newspapers ran photographs of muddy roads and shivering families, while headlines demanded answers. The Detroit Free Press gave the plant a new name: Will It Run? As if the world's largest factory was just another broken-down car. Inside the plant, the night shift pressed on. On October 12, 1942, the Davis wing assembly line was running when a sharp crack echoed across the floor. A main spar had fractured. The wing box collapsed in front of stunned riveters. Accident reports traced the failure to a misaligned drill guide off by just 0.03 of an inch, but enough to concentrate stress and snap the slender aluminum spar. Photographs from that night show a twisted wreck, the promise of precision shattered by the wrong tool and a worn jig. Eyewitness accounts recall a foreman yelling that they were building a bridge, not a bomber. Production stopped cold while engineers combed through the debris, searching for the root cause. The press seized on the disaster. Editorials called for real aircraft engineers, not carmen, to take charge. Congressional hearings followed, grilling Ford's executives about the collapse and the lack of finished planes. Representative Claire McDonough demanded, "How can we trust a factory that cannot deliver a single bomber while the war rages?" Behind the scenes, the War Production Board issued a blunt ultimatum: deliver 100 aircraft by May 1, 1943, or face government takeover. A White House memo warned that continued failure would mean the Army would seize the plant outright. For the workers, the threat was real. Every shift felt the pressure. The Willow Run label hung over the plant, a daily reminder that their jobs and the entire experiment were on the line. The crisis had reached its breaking point. Something fundamental had to change, or Willow Run would become a $200 million monument to American overconfidence. Late 1943 at Willow Run looked nothing like the chaos of the year before. The plant had become a living experiment in industrial reinvention, its future staked on a total overhaul of how bombers were built. The first step was a contract blitz. Ford signed off on orders for 1,600 specialized aviation machine tools, each one engineered to do what no automotive press ever could. Multi-directional drills from Pratt & Whitney arrived by the dozens, their 6-axis heads able to pierce aluminum spars in 3 dimensions, holding hole positions within a margin of just 0.005 of an inch. Dodge Metalworks delivered new milling stations, spinning at 12,000 revolutions per minute, able to shape wing ribs without warping or crush marks. The old flat jigs were scrapped. In their place, engineers installed 3-dimensional fixtures, giant steel frameworks with micrometer-driven slides, each one custom-built for the Davis Wing's impossible geometry. These jigs locked every spar and rib into perfect alignment, eliminating the cumulative errors that had once twisted entire assemblies out of spec. But tools alone did not solve the human problem. The tightest spaces, the tail, the wing roots, the bomb bay, still stalled the line. So Ford's team recruited midget crews, squads of workers under 5 feet tall, many of them women, trained for jobs that required crawling inside the narrowest compartments. Foreman John Hirsch ran a 2-week crash course on reading blueprints, using micrometers, and setting torque on rivet guns. The result? Cycle times in the tail section dropped by half, and rework rates for tight space assemblies fell by nearly a quarter. Specialty crews, each assigned to a specific pattern or bracket, became the plant's secret weapon, able to move with a precision and speed that no car line veteran could match. The assembly line itself was ripped up and rebuilt as a 1.5-mile L-shaped river of steel. Subassemblies flowed in parallel, converging at a central keel where the Davis Wing, now held in a jig accurate to plus or minus 0.005 inches, was finally mated to the fuselage. Automated conveyors moved parts from station to station, while gauges and inspection fixtures tracked every dimension in real time. For the first time, every critical part was truly interchangeable. The days of hand-fitting and endless rework were over. Each fix, every new tool, every specialty crew, every jig, mapped directly to a failure that had once stopped the line. Now, the plant was finally capable of building bombers at the speed and precision the war demanded. By the summer of 1944, Willow Run was no longer a punchline. The plant that once struggled to finish a single bomber now ran with an energy that bordered on the unbelievable. Every 55 minutes, a complete B-24 Liberator rolled off the end of the 1.5-mile assembly line, faster than Henry Ford's original 63-minute boast. This wasn't a fluke. Production logs show a relentless, almost metronomic tempo. Day and night, 7 days a week, the line delivered a new bomber with a regularity more familiar to a watch factory than a war plant. The numbers tell the story. In less than 2 years, Willow Run's output climbed to 8,685 B-24s, more than half of all Liberators built during the war. The workforce, once paralyzed by inexperience and poor conditions, now counted 40% women. They filled every role, from riveter to crew chief. Midget crews, many under 5 feet tall, worked deep inside the tail sections, driving cycle times down and rework rates to record lows. The plant became a proving ground for the industrial power of women, with over 15,000 on the payroll by 1944. Efficiency gains were staggering. Man-hours per plane plunged from 200,000 to just 18,000. The cost to build each bomber fell from $238,000 to $137,000. These weren't just accounting tricks, they were the direct result of new tools and new thinking. The The 1,600 specialized machines, from 6-axis drills to torque-controlled rivet guns, brought tolerances down to plus or minus 0.005 inches. For the first time, every critical part was truly interchangeable. Scrap rates dropped, final assembly sped up, and the endless hand-fitting of the early days disappeared. The river of steel assembly line, flowing in its L-shaped path, allowed parallel subassemblies to merge like clockwork. Inspection gauges tracked every dimension in real time, catching drift before it could become disaster. The plant's own quality control charts, once a litany of failures, now showed a stable statistical process with defect rates below 5%. None of this happened in isolation. It took tens of thousands of workers, many of them new to industry, learning to trust in measurement, teamwork, and the discipline of the line. The result was not just speed, but a new kind of reliability. By the end of the war, Willow Run had turned from a monument to overconfidence into the world's most productive bomber factory, a place where numbers, not promises, finally told the truth. The story of why the world's largest factory produced 0 planes for a year continues to unfold. As new evidence emerges and time passes, the questions that remind us why seeking truth matters. The search continues.